The Chemistry Behind Lava Lamps by Haley Scheffler and Maya Farhad. First, we'll talk about who made the first lava lamp or who invented them. They were invented by a man named Edward Craven Walker after observing an interesting-looking lamp in a pub. They were first considered ugly and useless at the time of its invention, but then they became extremely popular among the hippies in the psychedelic era of the 60s. Now, the components of a lava lamp are very simple. It's just a glass bottle, a light bulb which is placed at the base of the bottle, and then a compound of waxes that make up the floating and sinking blobs, and then a component of water and additives that makes up what these blobs float in, and we'll talk about those later. Okay, what is the wax made of? The wax in a lava lamp needs to be light enough that it will float when it's heated, and it's mostly paraffin wax, which is the most commonly used wax in the making of lava lamps. And that picture right there is paraffin wax, just sheets of paraffin. The liquid in a lava lamp is mostly just water and oil, and they're usually comprised to make up the liquid that the melted wax floats in. And the most common combination of substances is mineral oil, distilled water, and isopropyl alcohol, which are pictured below. When you plug in a lava lamp, the light bulb turns on and heats the contents of the glass bottle, and it takes about 20 minutes. And after being completely heated, the colored blobs of wax rise to the top, and when they reach the top, they cool down and they begin to fall down to the bottom as new blobs begin to float up to the top. So it's like a little continuous cycle. So why does this work? So now to the more important stuff. What's the chemistry behind all of this? When the lava lamp is at room temperature before anything is heated or plugged in, the water is slightly less dense than the wax, so it floats on top of the wax. And then the waxy substance absorbs the heat produced from the light bulb and becomes less dense. That is, after 20 minutes when it gets really hot. And because of its new density, it will begin to float to the top. And then when the wax gets farther away from the bulb, it cools down and becomes denser than the water compound. Therefore, it will begin to sink back to the bottom of the bottle. And now to get a little bit more in-depth, the key to the falling and rising of the blobs is based on the rate at which they thermally expand. So when the mixture of these two compounds reaches its equilibrium temperature, the rate of expansions are different. This thermal expansion is what causes the molecules to become more close or more spread apart. The molecule placement is what causes the waxy blobs to become denser or less dense. The densities of the waxy blobs is what causes them to rise or fall. So basically what this means is that when the wax blobs get heated, they absorb the heat molecules and they move a lot quicker. So they expand and they become less dense, so they rise. And then once they reach the top, since the light bulb is at the bottom, it cools down and then it drops and the molecules become more compact. And just to sum up this entire presentation, we have a little diagram of a lava lamp, and as you can see, the bulb is at the base, so the heat can reach the solid waxy compound, which is right above it, and then there's a surrounding liquid where the bulbs move around in, and here where it says warm, it says as the waxy compound is heated, the molecules spread apart, making it a lighter density, which is what I said, and then the rising blob cools, causing its molecules to move closer, making it a greater density. And just to go along with the previous diagram, here's an actual working lava lamp in action. And as you can see, the little blobs are going up and down, and the top one is about to fall because it's cooling down and the molecules are becoming more compact. And now, see, there it goes, it's falling. And then there's a rising one right there, and it's just this continuous thing until you turn it off. And this concludes our presentation about lava lamps, and me and Haley both hope that you've learned more about lava lamps and how they work.